Hello and welcome to the mathematics class. Now today my topic is surds. Now in few books it is given as a separate heading in the chapter rational and irrational numbers. In few books it is a separate chapter with the name or with the heading surds. So I will be discussing all those things which are important in this chapter, because after understanding surds you will be able to solve the topic rationalization that is already there in your first chapter, rational and irrational numbers. So first of all, the question is, what are surds? This is a new thing, I think. Initially it was there in the syllabus, but later on it was all not there. Now what are surds? If A is a positive rational number, Q stands for rational number. If A is a positive rational number and N is any positive integer, I hope you all know integers and the positive integers from 1, 2, 3, 4 and up to infinite. So if N is a positive integer and A is a positive rational number, and if after these two conditions are fulfilled, if nth root of A is irrational, if nth root of A is irrational, then nth root of A is known as surds. So what are the two important things that are there or that should be there for an expression to be surd? First thing is, there should be a positive rational number, and second, its nth root should be an irrational number. If these two conditions are fulfilled, then it is a surd. For example, I take 5. 5 is a positive rational number. I take its square root. We all know that square root of 5 is irrational number. So under root 5 is a surd. Suppose I take 8 and I take its cube root. We know that 8 can be written as 2 to the power 3 and nth root or cube root can be written as 1 upon 3. According to the laws of exponents, this will be 3 into 1 upon 3. This and this cancelled, you will get 2. This 2 is a rational number, means finally you are not getting any irrational number. So this is not a surd. This is a surd. It means that if any nth root of a rational number is irrational, it is a surd. If nth root of any rational number is not an irrational number, it is not a surd. Means nth root A, if it is irrational, then it is a surd. In this case, in this expression, nth root of A, n is the index, root sign is radical sign, and A is known as radicand. Let's take one more example. Suppose I say under root 2 plus under root 3 is irrational number. Suppose I compare it with A. So A would have been what? Rational number, but here it is irrational number. So this is again not a surd. Even when you talk about only 2 plus root 3, this is again irrational. So one condition it is satisfying, that nth root of A is irrational. So it is irrational, but since the number itself is not rational, it is not satisfying the first condition, that A is a positive rational number, but 2 plus root 3 is irrational, so therefore it is also not a surd. So to justify a given expression as a surd, it should fulfill both the conditions. It is mandatory that first A should be positive, A should be a positive rational number, and second that nth root of A should be an irrational number, then only it will be a surd. Now the next thing is how to compare the surds. Now in this you can see that the index is different. This is cube root, this is fourth root. If the index would have been same, suppose I say square root of 8 and square root of 15, then it is quite easy because the index or the radical, this is of second order radical sign, second order. So simply this is 8 is less and 15 is more. Means when the powers are same, then you can simply make it out which one is bigger or which one is smaller. But in this case, when you have different powers, different radical powers, first is third root, then it is fourth root. So what are we going to do? We will take the LCM of these powers 3 and 4. LCM of 3 and 4 is 12. We will convert both these in the form of same radical numbers. Means this cube root of 3 can be written as 3 to the power 1 upon 3, and fourth root of 5 can be written as 5 to the power 1 upon 4. We have to write it as 12. It means this can be written as 3 to the power 4 upon 12. 1 upon 3 can be written as 4 upon 12. At the same time, this can be written as 5 to the power 3 upon 12. It will not change. 1 upon 4 will be 1 upon 4 only, and 1 upon 3 will be 4 upon 12. But the question is that this initial expression should not change. Here you can see initial expression is not changing. It means we can say that 12th root 3 to the power 4. 3 whole power 4 upon 12 can be written as 12th root 3 to the power 4, and this can be written as 12th root 5 to the power 3. Now 3 to the power 4 is 81, so it means 12th root 81, and this means 12th root 125. Now you can see both have the same powers, 12th root. Now you can easily make out which one is bigger. 125 is bigger and 81 is smaller. So you can put a sign like this. That is your final value. So this is how we compare when you have been given two surds of different orders. This was of order 3, this was of order 4. What we do, we take the LCM and we convert both the orders with the same number. That is, you can see here it is coming 12, here the order is 12, here order is 12. But this value we can easily make out. So that is enough about the surds. That is for your use. There are so many things, but now we move on to the rationalization. This is very important, and one question is fixed in the exams of this topic. Now what is rationalizing factor? If the product of two surds is a rational number, if the product of two surds is a rational number, then each one of them is said to be rationalizing factor of each other. For example, I say 3 plus root 2. Now you know that root 2, if one is positive, then other factor would have been negative. So the other factor can be written as 3 minus root 2. If you multiply these two, a plus b, a minus b, that is a square minus b square, so you will get 3 square minus root 2 square. That you will get as 9 minus 2, that is 7. Finally, you are getting a rational number. If the product of these two surds or irrational numbers, product of these two surds is a rational number, then each one of them is known as rationalizing factor of each other. Suppose I say root 5. What is the rationalizing factor of root 5. So, stop. Suppose I say root 5. So, what is the rationalizing factor of root 5? It can be k times root 5, where k is any non-zero rational number. When you will multiply these two, you will get 5 times of k, where k is a non-zero number. Means this can be anything, any rational number except 0. So root 5 into root 5 will give you 5 times of k. Suppose I say, what is the rationalizing factor of 2 root 5? So simply, this is irrational number or this is a surd, you will multiply by root 5 and final value will be 2 into 5, that is 10. Now I have taken two questions, and these questions, in these questions you have to rationalize. What you have to rationalize? Rationalize the denominator. Denominator here is root 11. So in order to rationalize the denominator, what are we going to do? We will multiply, since you can see that this is root 11. So here if it comes 11, then the denominator will be a rational number. So to make this denominator as 11, we need to multiply by root 11 also. It means 2 root 7 upon root 11 into root 11. Now since root 11 has been multiplied to the denominator, it has to be multiplied to the numerator also into root. So I have done this. So 2 upon this will become 11, and root 7 into root 11 can be written as root 77. So that is the final value. Means you have to rationalize the denominator. So denominator is in the form of a rational number. Second question, 2 minus root 3 upon root 3. Here what are we going to do? Now you are able to make out. We will multiply by root 3 in both numerator and denominator. So this will be 2 minus under root 3 times root 3 upon root 3 into root 3. It will come as 2 minus root 3 times root 3 upon 3. That is the final value. Now we will be taking a few bigger questions that come in your exam. Next question is root 7 minus root 5 upon root 7 plus root 5. Here also you have to simplify. The question will come as simplify or rationalize the denominator. So I am saying that this question, suppose this question is simplify. Simplify means that if the denominator is in irrational form, you have to convert it into a rational form. Now this is root 7 plus root 5. So its conjugate or rationalizing factor or RF will be root 7 minus root 5. So root 7 minus root 5, that was the question. I have to multiply by the conjugate or by the rationalizing factor both in the numerator and denominator. So it will be root 7 minus root 5 upon root 7 plus root 5 into root 7 minus root 5. What I have done? I have, since this is given root 7 plus root 5, so I can easily make out that its rationalizing factor will be its minus sign. So root 7 minus root 5 is multiplied to both numerator and denominator. This will be root 7 minus root 5 whole square. This is same, this is same. So when a number is multiplied to itself, it can be written as square. So I have written as square. And this is a plus b, a minus b. That is a square minus b square. So that will be root 7 square minus root 5 square. So it will be under root 7, that is a square plus b square minus 2 root 7 into root 5 upon 7 minus 5. That can finally be written as 7 plus 5 minus 2 root 35 upon 2. 7 and 5, 12 minus 2 root 35 upon 2. Now from the numerator you can take 2 common. So 2 common, 6 minus root 35 upon 2, 2 and 2 cancel. So final value is 6 minus under root 35. What I have done? I have taken the rationalizing factor. Since this was positive, so obviously the rationalizing factor will be negative of the same expression. That is multiplied to both numerator and denominator. Because these are two same numbers, so square, and this is according to the formula a square minus b square. So a square plus b square minus 2ab, and square of root 7 is 7, square of root 5 is 5, 7 minus 5 is 2, 7, 5, 7, 5 and 2 root 35, and we simply solve it out. Now one more question I will be taking, that is 3 upon, let's take it as 3 upon 5 minus root 3 plus 2 upon 5 plus root 3. We have to simplify this question, or this, we have to find the solution of this. So let's take, in this what will be the rationalizing factor? 5 plus root 3. And in this what will be the rationalizing factor? 5 minus root 3. So what I am going to do, I will multiply by the rationalizing factor, that is 5 plus root 3 in numerator and denominator. 5 minus root 3 into 5 plus root 3. Then there was a plus sign, so I made a plus sign. Then 2 times of 5 minus root 3 upon 5 plus root 3 into 5 minus root 3. This is a square minus b square and a square minus b square. So this can finally be written as 3 times 5 plus root 3 upon 5 square is 25, 25 minus 3 plus, this will be 2 times of 5 minus root 3 upon 25 minus 3. Both of them will be having the denominator as 22. So I am taking LCM as 22. 25 minus 3 is 22. 25 minus 3 is 22. So here if you want you can write 22, and here also 22. So I am writing 22 over here as a LCM. So this will be 3 times of 5 plus root 3 plus 2 times of 5 minus root 3 upon 22. That can be written as, you can open the bracket. So 5 3s are 15 plus 3 root 3 plus 5 2s are 10 minus 2 root 3 upon 22. 15 and 10 is 25 plus 3 root 3 minus 2 root 3 will be 1 root 3, or simply root 3 upon 22, and that is the final value. Final value means you have already rationalized the denominator, or this has been simplified. That is all. Now this question, this type of question I am sure you will get in the examination. The question is 5 plus 2 root 3 upon 7 plus 4 root 3 is equal to a plus b root 3. Find the value of a and b. You have to find the value of a and b. First of all, what we will do, we will rationalize the denominator. Now this is 7 plus 4 root 3. So its rationalizing factor will be 7 minus 4 root 3. It means we are going to multiply by RF, or rationalizing factor, both in numerator and denominator. So solution, my solution will be 5 plus 2 root 3 into 7 minus 4 root 3 upon 7 plus 4 root 3 into 7 minus 4 root 3. What I have done? I have multiplied with rationalizing factor both in numerator and denominator. Now this will be simply multiplication. 5 into 7 is 35. 5 into minus 4 root 3 is minus 20 root 3. 5 4 is 20. So 7 plus 2, 7 into 2 is 14 root 3, and 2 into 4 is minus 8 root 3 into root 3 is 3 upon this will be a plus b, a minus b. That can be written as a square minus b square. So simply 7 square minus 4 under root 3 square. Now we will solve them. 35 minus 24 is 11. 8 3 are 24. 35 minus 24 is 11. So this and this solved. 35 minus 24 is 11. Now minus 20 and plus 14 will be minus 6 and root 3. Now in the denominator 7 square is 49 minus 4 4 is 16 and root 3 into root 3 is 3. So 16 3s are 48. This becomes 48 and finally it becomes, I am writing it here, it becomes 11 minus 6 under root 3 upon 1 and that was given equal to a plus b root 3. When you compare them, you will compare this value with this value and minus 6 root 3, this third will be compared by this third. So a you will get as 11 and when you compare 6 under minus of 6 under root 3 by b under root 3 will cancel, you will get b is equal to minus 6. So you are getting b as minus 6, that is the final value. We will take one more question to clarify the concept. Let's move on. Next question I am taking, if x is equal to 1 x minus 1 upon x whole cube. So you know that x is already given 1 minus root 2. What will be the value of 1 upon x? 1 upon x will be 1 upon 1 minus root 2. Now this is irrational number. So in order to rationalize the denominator, we will multiply with the rationalizing factor, that is 1 plus root 2 both in numerator and denominator. So it will be 1 plus under root 2 upon a minus b into a plus b is a square minus b square. So you will be getting as 1 plus root 2 upon 1 minus 2, that is 1 plus under root 2 upon minus 1, or this can be written as minus times of 1 plus under root 2. 1 minus 2 is minus 1. Since minus is in the denominator, we put it in the numerator and we remove the 1. So it is minus of 1 minus of 1 plus root 2. Now x minus 1 upon x will be what? X was 1 minus root 2 and minus 1 upon x means minus of 1 plus root 2. That will be 1 minus root 2, this and this will become plus 1 plus root 2. Plus root 2 minus root 2 cancel, you got as 2. It means x minus 1 upon x whole cube will be 2 cube and that is 8. That is the final value. I hope this is clear to you. Let's move on to one more question. This question is present in so many books and this is a very general question. Once you look at this, you feel it is a very long question, but I will say this is very small question completely based on the topic. Suppose you consider the first part, 1 upon 1 plus root 2. In order to rationalize the denominator, what are you going to do? You will simply multiply the conjugate of this, that is 1 minus root 2 in the numerator as well as in the denominator will be 1 plus root 2 into 1 minus under root 2. I am solving this part only and on the basis of this we can write all the other parts. Now this will become 1 minus root 2 upon 1 square is 1 and minus root 2 square is 2. So finally you are getting 1 minus root 2 upon minus 1. In the same way, in this you will be getting, in the second part you will be getting root 2 minus root 3 upon minus 1. Similarly other parts. So I am writing just the third step. So that is 1 minus root 2 upon minus 1. Then plus plus root 2 minus root 3 upon minus 1. Then plus root 3 minus root 4 upon minus 1. Plus root 4 minus root 5 upon minus 1. Plus root 5 minus root 6 upon minus 1. Plus root 6 minus root 7 upon minus 1. Plus root 7 minus root 8 upon minus 1. Plus root 8 minus root 9 upon minus 1. Everywhere you will be getting the same. Now when minus is in the denominator, this term can be written as minus 1 plus root 2. First term. Second term can be written as minus root 2 plus root 3. Minus root 2 plus root 3. Then third term can be written as minus root 3 plus root 4. Next can be written as minus root 4 plus root 5. Next can be written as minus root 5 plus root 6. Next minus root 6 plus root 7. Minus root 7 plus root 8. Minus root 8 plus root 9. Minus plus 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 cancelled. Finally you are left with minus 1 plus root 9. You know that root 9 is 3, so minus 1 plus 3, so final value is 2. So that is all for today. This was about rationalizing the denominator. In some books it is there in the last part, rationalize the denominator, find the value of a and b, and so many questions. I have discussed almost all type of questions that are present in your textbook. So I expect everybody to revise and solve the questions and do as much as practice you can. Next I will be coming with the chapters factorization. Thank you. Stay home, stay blessed, and please subscribe. Thanks a lot.